Hey everybody, it is Professor Diffley. This is History of Springfield, History 114. So this is Module 2, Lecture Video 3. So we left off with the difference between semi-nomads and nomads. Here's where we're picking up in Lecture Video 3, the origins of humans in North America. And so now a sub-area that is creating the CT Valley and some geological history on it, because it really does shape when people... well, geology obviously, shapes the region, and then about how people used and the first peoples utilized and why they settled here and how it's changed over time. And so this is something that you get in a full geology course, but some real important back concepts. Also, where we're going back way long time ago, late Paleozoic era, late Triassic, up to 230 million years ago, Pangea and the rifting of the continents. And it's going to help explain how the Connecticut Valley came to be. And we're going to see there's required videos on Blackboard. Again, they're about 3 to 5 minutes. I'm actually going to show part of it here in this lecture video, because it is important, and it really does, for other people, you might know about the dinosaur tracks that can be found throughout the valley in different areas, in this part of it. But going all the way back, to Pangea, this was the supercontinent, right? Where 280 million years ago, evidence says that all the continents that we know today were once combined, right, into a giant supercontinent called Pangea. And it's there at Pangea where North America meets what would be today's Europe and parts of Africa, especially up in the northeast here, what we call the northeast today. There, and that's where the dinosaur tracks were, right? And that's where they came from. Is when you had this giant, supercontinent in many ways, and one of the videos talks about how we get to see them. But this rifting, this great rift, this Rift Valley created pretty much here where we are in the Northeast, along the coasts, and all the way to up here in the Connecticut River Valley, really what is New England. Eventually what happens is the continent, the plates begin to shift and drift apart. A great rift is created, and they begin to pull apart over time. And today the continents are still drifting, that sort of thing. But that started right here. And so that's why it's the edge of eastern North America here. And it begins to pull apart. Eventually, fast forward 280 million years to today, and you get the continents as they look today, and they are still drifting apart, right? North America and Africa are drifting apart. I think it's about 2.5 centimeters per year. They continue to move apart. And again, that will be discussed in one of the videos where we're going to take a look now at this global glacial forces the tracks revealed. These are the two required videos. This really describes the rift, how the Connecticut River Valley was formed, and this goes a little bit more into the dinosaur tracks. And you see here, there's some more other suggested videos. Let me just talk about those. These two are really about, it's from a cultural competency training, but it talks about Native Americans and Native American culture. It suggests to watch that. This is also a full lecture given by about the Mount Holyoke Range, Mount Tom, all the geology of there by a famed professor of the leading geologist of the Connecticut Valley, Professor Richard Little. So if you're interested in that sort of thing, really take a look at this. But the two videos that are required give a good synopsis of it and what you need for this class. But again, if you're interested in that, definitely take a look at that. So let's take a look at the videos here. And again, you can see this is also just for an overview thing, the videos. Up here you have the YouTube URL, so if you want to go watch it outside of here, but it does give you a little player here. And so this stuff is important. I want you to see this. So for the next a few minutes, we're going to watch this, and this is what I would do if we were in class anyway. All right, let's take a look at this.
What we're standing before here is a model of the Connecticut River Valley, the period being the last glacial period. We're looking at a model that has the ice that was in the valley retreating. This is some 15,000 years ago. And it covered the region about 20,000 years ago. But we're going to take a step back first and talk about what this ice was covering. About 200 million years ago, this valley opened up. And when it opened up, during the breakup of Pangaea, it was an opportunity for things to live. And the things that lived in the valley some 200 million years ago were dinosaurs. They roamed the valley, leaving their footmarks in places here, there, and everywhere within the valley itself. And it was Edward Hitchcock who, in about 1835, first began to scientifically articulate what these marks were that were found in the muds and the sands that were the rocks that he found beneath his feet. Had it not been for these glaciers, those rocks would not be the rocks that would be beneath his feet. The glaciers came through and literally scoured the valley of all of the debris, layer after layer, exposing what we see today. Ice ages are a normal part of what happens on the Earth. What occurs is you begin to have this evaporation that occurs off of the oceans. So the evaporation comes off, and then it comes down as snow on the poles. Evaporation, snow, evaporation, 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 snow over literally hundreds and hundreds of years. The snow builds up, the ice pack gets thicker, and as it gets thick enough, it begins to slowly push itself down under the weight of the ice, and it moves down into the continental areas. And as it does so, it eventually reached all the way down to what is now Long Island Sound, Nantucket, and Martha's Vineyard, where the ice sheet covered, and in Amherst in particular, it was close to a half-mile deep. As the ice moved into this region from north to south, it began to slowly creep down. Literally, a mile thickness of ice is beginning to move over our region. And as it does this, the ice on the very bottom of the glacier is melting. And the water is beginning to seep into the cracks between the rocks, the bedrock. And as it seeps into the cracks, it refreezes, expands a little bit, cracks the rock open, and embeds that rock, plucks it out of the bedrock into the glacier itself, plucking one rock after another, after another, after another, until it's plucked. All of the debris and all of the rock from this region is being plucked and carried. So it's scouring all of New England, just ripping up the last pieces of sediment, all the way until it reached Long Island, Martha's Vineyard, Nantucket, and Cape Cod. The debris was brought down to this point, and where the debris ended up being deposited, creating what's called an end moraine, is Long Island, Martha's Vineyard, and Nantucket, all in through here. Then the glacier slowly began to retreat back, and as it did so, it was retreating and it was melting back, and as it melted back, there was a place that a fair amount of debris was deposited where the Connecticut River Valley had opened many years ago. And that area ended up creating what is now called Rocky Hill, Connecticut. Hence, Rocky Hill, it's a pile of rocks. The entire region is completely blocked off with rocks that were deposited. And as the glacier began to melt back, water collected behind that natural dam. And as it collected behind the natural dam, it created this lake that extended from Rocky Hill, Connecticut, almost to the Canadian border. To get a little perspective here, the mountain range in the foreground is the Holyoke Range. Mount Tom is over here. You come up and you have Mount Sugarloaf here. The blue indicates Glacial Lake Hitchcock. This moment in time where the glacier has retreated to about Mount Sugarloaf is about 13,000 years ago. It was Edward Hitchcock's role as the state geologist that brought to him a bevy of information. That information was geologic evidence related to glaciers being in the valley. Those glaciers that came through the valley scoured the valley, exposing rock that was nearly 200 million years old.
There, and it gives you
and it's that 200 million year old rock where the dinosaur trackways were found.
And I grew up on Long Island. That's where I'm from, the North Shore there, and you can see the evidence of what they're talking about, where that was the leading edge of the glacier. On Long Island, there's the North Shore, which is on the Long Island Sound, and the South Shore, which is on the Atlantic Ocean. And the beaches couldn't be any more different. So the beaches on the North Shore are all rocky. The beaches on the bottom, on the South Shore, are like, fine sand, soft sand. Why? Because of where they, the rocks had been crushed down to sand and, at the very, very far edge of the glacier being pushed. and deposited across there. You can see this stuff, and on where that line is, you can find lines of giant boulders that are just dropped out of where, Wyoming's flat land, just dropped out of seemingly nowhere, and they can actually trace them all the way back up to mountains up in New Hampshire and Maine and Canada and things like that. Other parts of that too, around here. And you could see where he said, where they're down by Rocky Hill, Connecticut, there were giant boulders that created the mountain, right? That's why it's literally Rocky Hill. But around this area, just go dig outside in the ground somewhere. It is incredibly rocky. The ground is. It is. That's going to have an impact later on the settlement by Europeans, right? It's going to be harder to farm large scale up here. Also with the weather, but you can see this there. That's why there are all these giant rocks just buried underneath. Go dig in a yard somewhere or anything like that. You will find in New England, especially around here, I mean, in the Connecticut River Valley, the evidence of all of this. And so, just moving on to, again, and that's, tells you where the dinosaur tracks. You can see them up by Holyoke. There are some throughout the region, and that, so you could check those out too. And that, that can be part of the history of this class we're doing. So later when we talk about a final project in this class, it's going to be about whatever you guys want to research, whatever you want to discuss about this area and its history. If that's something you're into, again, make note of it, and we can talk about other resources. But that is all part of this there. So. Going forward, so we talked about the Ice Age, and that's the ice sheet there, the Laurentide ice sheet. This is the Pleistocene epoch, about 1.7 million years ago to approximately, and there's a typo in there, sorry, 15 to 10,000 years ago, right? The last great ice age, as they call it, where glaciers really did cover much of the northern hemisphere. Again, approximately 15,000 years ago, this led to the spread of glaciers, like we said. Sea levels dropped, right? And so, because all these ice, as they said in the video there, it's evaporated and then turned into snow and ice there. And so, as the sea levels drop, it exposes more land. And now this is about how people got to the Americas. And this exposed a land bridge, what becomes known as Beringia, crossing, for the Bering Sea, what is Alaska into today's Russia, connecting Asia and North America. Now, one thing, when we say a land bridge, don't think of a bridge you go over with cars. It's really a giant isthmus, right? People would not have known they were crossing over, like you could tell you're crossing over a bridge or something like this. It's an isthmus. An isthmus is a body of land with water on two sides of it, right? Think of Florida, that's a peninsula, and islands, obviously, all water on all sides. An isthmus is two sides. And so that's what this was. People began to cross this, and here's an image of it, of Beringia. People moving from what is Asia into the Americas and down. Now, it wasn't as cold in Alaska. I mean, it was, but, it's different at that point. But it showed all of this, the land up there, these land areas. This is how much the oceans had fallen because of the Ice Age. And so this allows people following game and herd. I mean, you can see that's gigantic. Alaska is huge. I mean, this is as wide as Alaska. If you dropped Alaska on a map of the 48 continental states, it would take up most of it, or a significant portion. It's multiple times bigger than Texas. Just to give you an idea of it. But here you can see this is the theory on how humans came over to North America. They moved over across Beringia, went across the West Coast down into Mexico, what is Mexico, Central America, and South, and then later up into the Northeast and other parts of the eastern part of North America, Canada, the United States today. And they talk about, this is the stuff about Glacial Lake Hitchcock that once occupied this area. And you can see up here too, this is the back edge of the glacier that we were just talking about in the video there. And you can see this one's covered all the way here. Again, the idea, and you heard the story, the dam eventually, created a dam at Rocky Hill, and that was the lower edge of it. And then, where did it go? Well, eventually that rock dam broke, right? And that's where this story is. It drained out. Eventually it broke. It drained out and created the lower 50 miles of the Connecticut River, right? As things began to thaw, and the lake drained and made the river. And you can see this in one of the Pocumtuck oral traditions here. The people of Beaver Tail Hill Amskawala kayak. I'm not very good at pronouncing this. I apologize when I butcher things like that. I butcher most names of anything. But, it's unclear. But it seems possible that the first Paleo Indians, first Native Americans, witnessed this. They were here for the great glacial Lake Hitchcock and its draining. And that's actually what we'll pick up in lecture video 4 for module 2. All right.